In example 2, we need to find the area of triangle DEF, and we're given that D is 13.9 inches, so that's our unit. Measure of angle E, we're also given, and the measure of angle D. Let's draw a triangle. It doesn't have to be perfect. We just want to see where these sides line up. If you prefer to be a little bit more accurate, then you can, of course. And we've got D, E here, and F. So E is 14.8. And let's see, D is 34.4. And then we've got the side opposite here at 13.9. So right now it doesn't look like we have two sides and an included angle. We don't even have two sides, we just have the one. So what we could do here is we could do really a few things. If we did E, if we found E here, we could also find F pretty easily using our triangle sum theorem, 180 degrees for all three angles. And then we could do our area formula with sine. So let's find that angle real quick, and then we will see if we can find side E. So we'll take 180 minus 14.8 minus 34.4, and that's 130.8. Obviously this triangle is not drawn to scale. If you prefer, you could draw another triangle if that helps you see where things are. So now we just need to find E. To find E, this is not a right triangle, so we need to use the law of sines or law of cosines. I think for us we've got an angle and an opposite side, so it's going to be pretty easy to find side E using the law of sines. So we'll have E over the sine of its opposite angle, and then we're going to use D here, so we'll do 13.9 over sine of 34.4. Then we can multiply by sine 14 on each side, so we're going to have 13.9 sine of 14.8 degrees all over the sine of 34.4. And we can type this into the calculator, 13.9 sine of 14.8. Be sure to close your parenthesis there, it'll really mess things up. And sine of 34.4. Okay, 6.3, about 6.3 here for E. And let's see if that makes sense in context. We've got 14.8 and an angle here that's more than double that. And our side length here is 6.3, and then the side length opposite that, 34.4, is a little more than double. So that does make sense. Let's use our area formula now, which will be 1/2 times the two sides times the sine of the included angle, so it'll be 130.8, the one that we found before. And hopefully this time I type it in. If you're following right along with the videos, made a little whoopsie, made another one here, or almost did, on the last video, so it's a good idea to think about kind of where this area should be. And let's see, we've got sine of 130.8 here, and I think this area probably is going to be around maybe 30 or 40, something like that. That might be might be a good measurement. So 33.1, that seems to make pretty good sense. So we'll go, the area is approximately 33.1. Because we're given inches up here, we want to list our unit, and of course that's inches squared. We're multiplying inches by inches here. If you prefer to leave them in there, you could. That would lead you directly to the proper unit as well. So that'll be our final answer here. It's about 33.1 inches squared, the area of that triangle.